Hello, good morning everyone. I'm Shochan and this is my complex engineering project on an automatic doorbell ringer for Triple E. Coming to the abstract, the automatic doorbell ringer is an innovative device designed to enhance convenience and accessibility in residential and commercial settings. Utilizing advanced motion detection and proximity sensors, the system automatically activates a uh, doorbell mechanism when a visitor approaches with a predefined range, eliminating the need for manual pressing. The device integrates seamlessly with existing doorbell systems and offers customizable sensitivity settings to adapt to various environmental conditions. Powered by a low energy consumption module, it ensures long term reliability and minimal maintenance. The technology provides with a hands free solution, improving user experience for individuals with mobility challenges and enhancing efficiency in high traffic areas. Coming to the objectives, it enhances accessibility, designing the automatic doorbell ringer to provide a hands-free solution, improving usability for individuals with mobility impairments or disabilities, improving convenience, automate the doorbell activation process using motion or proximity sensor to ensure seamless operation for visitors within residential and commercial environments, ensuring compatibility, developing a device to integrate effortlessly within existing doorbell systems, allowing easy installation without requiring extensive modifications. Optimizing energy efficiency, incorporating a low power consumption module to maximize the device's operational lifespan and minimizing maintenance or replacement battery needs. Enabling customization, including adjustable sensitivity and uh, range settings to adapt to conditions and user preferences, requirements for an automated doorbell ringer, programming skills, ability to program microcontrollers using languages like C or C++ for Arduino or Python for Raspberry Pi, networking skills, understanding how to set up and configure Wi-Fi networks, familiarity with IoT platforms for remote monitoring and notifications, safety precautions, knowledge of electrical safety practices to ensure safe handling and installation of electrical components. These are the functional requirements. Automatic detection. The system must detect visitors within a configurable range. Example, 0.5 to 3 meters using motion or proximity sensors and trigger the doorbell without manual input. The main goal is to make sure that the system detects humans properly or does not mistake them for something else by causing mishaps. So we should make sure the ideal range should be within 0.5 to 3 meters. Uh, we should set the ideal range within them and to make sure it triggers only when humans when we try to enter the or we try to ring the bell. Compatibility. The system must integrate with standard wired or wireless doorbell systems. It should be able to integrate already exist within the pre-integrated standard doorbell systems. Adjusting sensibility. Users should be able to adjust sensor detection range and sensitivity to different environments, high traffic areas or in quiet homes. This system should be able to be adjusted according to our needs and uh, should not be very hard to customize. The feedback mechanism, providing visual or auditory feedback, example LED or beep to confirm the bell has been activated. The weather resistance, the device must operate reliably in various weather conditions such as heat, cold, rain for outdoor installations. Low power consumption. The system should minimize energy use, supporting battery powered or low voltage operation for extended periods. It should not be hot wired, etc. It should be use minimal energy to be still, and also it should be supporting battery powered use also for reliable reliable mechanism. Non-functional requirements, reliability. The system must achieve at least 95% accuracy in detecting visitors while avoiding false triggers from non-human environments, example, pet sermon. As I said before earlier, we should make sure it only detects humans uh, and make sure it's in the proper range by not mistaking everything for humans and causing false triggers to happen. Durability. The device should withstand continuous outdoor use for at least a minimum lifespan of 5 years. Ease of installation. Installation should be user friendly, requiring minimal tools and technical knowledge achievable within 30 minutes. Installation should be done within 30 minutes and it should be user friendly, through which means anybody should be able to install it within 30 minutes. The compact design. The device must be compact. Example, it should be under 10 into 10 into 5 centimeters, which is almost as size of a wooden block to ensure discrete integration within existing doorbell setups. It should not take up too much space and it should be integrated within before the doorbell system, not to be appearing too concise. Cost effectiveness. The total cost of components and manufacturing should be target affordability for mass product production. Example under $50 retail, which means is almost around 5,000, etc. Safety and compliance requirements, electrical safety. The device must comply with relevant electrical safety requirements and standards, such example ULC for low voltage operation. Environmental compliance. The components must adhere to RoHS standards for environmentally safe materials. Data privacy. If connected to a network, the device must ensure no unauthorized data collection or transmission. If you're connecting it via Bluetooth or any other wireless network, you should make sure it doesn't leak any private data, and it should be reliable, only to be used by us properly, and uh, should not be able to be controlled by anyone else. Hardware components. It's a microcontroller unit. It's ESP32 or Arduino Nano for processing sensor data and controlling outputs purpose. It acts as a central processor to manage sensor inputs, doorbell activation, and user configurations. Specifications: 32-bit processor, 4 MB flash drive, Wi-Fi or Bluetooth, optional for smart features. Wi-Fi or Bluetooth, if you want to be able to use wirelessly, you should opt for the Wi-Fi or Bluetooth module. If you don't want to, it may be avoided. And coming to motion or proximity sensor, it's a passive infrared sensor. Example HC SR501 and ultrasonic sensor. According to your standards, you can take whichever one you want to. An infrared sensor is supposed to be a red laser, or an ultrasonic sensor is different. Uh, its purpose to detect the human presence or movement within the specified range. Specifications: detection range to of 0.5 to 3 meters, adjustable sensitivity, and 5 volt operation. Relay module component: 5 volt single channel relay module. Purpose: interfaces with existing doorbell system to trigger the bell mechanism. Specification: supports 5 to 12 volt operation, compatible with standard doorbell circuits. Coming to the power supply, a rechargeable lithium-ion battery, 3.7 volts or 2000 million amperes, or a 5 volt DC adapter with a battery backup. Purpose: provide power to the system, ensuring continuous operation. Specifications: low power mode for extended battery, 6 to 12 months minimum per charge. An LED indicator, a 5 LED green or red, your wish. It provides visual trigger that the doorbell has been rung, or so the specification should be low power within a 20 mA current draw. A buzzer, a component, 5 volt active buzzer. Purpose: emits a sound to come from doorbell activation for user feedback. Specifications: 85 decibel output minimum, and a 5 volt operation. Uh, Weatherproof enclosure component, IP65 rated ABS plastic enclosure. Purpose: protects components from environmental factors such as wind, rain, dust, etc. Specifications: dimensions 10, 8, 4 centimeters. Mounting brackets included. Uh, Push buttons on a potentiometer. Tactile buttons of 10 kilo ohms. Potentiometer allows user to configure sensitivity, range, and or reset a device. Durable, rated for 10,000 presses. Uh, PCB and connectors. Uh, Component, custom design PCB with screw terminals or JST connectors, which provides a stable platform for component integration and easy connection to external doorbell systems. Specifications is FR4 material compact layout. Operation optional Wi-Fi module for smart features. Built-in ESP32 Wi-Fi or external module. Node MCU. Purpose: enables remote notifications or integration with smart home devices such as Alexa or Google Home. Specification: 2.4 GHz Wi-Fi. Secure MQTT protocol support. This combination of requirements and hardware ensures a robust, user-friendly, cost-effective automatic doorbell ringer suitable for diverse applications. Installation and setup. Tools required is a screwdriver, double-sided adhesive tape, drill for wall mounting if needed. Steps: choosing location, selecting a spot near the door within 1 to 1.5 meters high, within 0.5 to 3 meters of visitor's approach path. Ensure this sensor has a clear line of sight and is protected from direct air or sunlight. Mounting the device: secure the weatherproof enclosure to the wall using provided mounting brackets and screws, or use adhesive tape for non-permanent installation. Align the sensor to face the desired detection area. Connecting the doorbell system: turn off power to the existing doorbell system. Connect the device relay module to the doorbell circuit using screw terminals. For wireless doorbells, pair the device for manufacturer instructions if compatible. Power the device, insert the rechargeable battery or connect the 5 volt DC adapter to a nearby power source. Verify the LED indicators to light up and confirm power. Configuring settings, adjust the potentiometer buttons or set the sensor's detection range 0.5 to 3 meters and sensitivity. Test by walking into detection zone. LED or buzzer should active and the doorbell should ring. Testing and finalization. Walk through detection area multiple times to ensure reliable triggering. Fine tune sensitivity to order false triggers from pets or wind. Secure all connections and close the enclosure. Time required should be up to 20 to 30 minutes. Should refer to user manual for specific wiring details. Testing in with different weathering conditions to optimize performance. For smart features, if included, connect to Wi-Fi via devices app as per the instructions. Should ensure that the doorbell system is powered up during wiring to avoid any electrical hazard. Technology used here, it leverages a variety of advanced technologies to enhance security and provide real-time monitoring system and alerts. There are some of key technologies used in the project. Motion detecting technology, uh, passive infrared rays or ultraviolet rays are radiation emitted by common movie launchers, commonly used for detecting human presence. Entry sensors, magnetic door of window sensors consists of magnet and sensor. When the door or window is open, the magnet moves away from the sensor, triggering the alarm. Communication technologies, Wi-Fi modules enable system to connect to the internet, send notifications to the homeowner's smartphone, allows local communication and control of alarm system using a smartphone app via Bluetooth. Camera integration, IP cameras captures video footage and streams it over to the internet for remote viewing. HD resolution provides high definition video quality for clear surveillance. Night vision allows the camera to capture images in low light conditions. Smartphone integration, if you have any smartphone connections or any wireless features through mobile, you can connect it to mobile apps or to push and can receive push notifications. There are also cloud services such as data storage or cloud storage. You can also do remote access from anywhere with an internet connection. AI technology using facial recognition, which identifies individuals and reduces false alarms, distinguishing between humans and uh, potential intruders. Voice control smart assistants integration with small voice control smart assistants like Alexa, Google Assistants, Apple Siri to control the alarm system using voice commands. Here is a dot block diagram which shows how is the system is arranged, as you can see here. And here is a circuit diagram for the entire system. Here's a sensor module. This is the infrared sensor. Here's a doorbell. This is the power source. This is a resistor. Is a relay. Is a power source. You can see that here how this works. By going near the doorbell, the sensor module receives a relay through which you can activate the buzzer. Coming to merits and demerits, contactless operation, no need to physically press a button, which enhances hygiene, especially useful in hospitals during pandemics. User convenience, automatically allows residents when someone approaches without visitor having to take any action. Accessibility helps elderly or disabled individuals who might have difficulty reaching or pressing a doorbell. Simple and inexpensive, using basic components like PRS, sensor, and a buzzer, making it affordable and easy to build. Low power consumption. The system only activates when motion is detected, conserving energy. Can be upgraded easily. Enhanced with cameras, guide IoT modules or app notifications for smart home integration. Demerits, false alarms may trigger buzzer due to any motion such as pets or wind-blown objects causing unnecessary alerts. Limited detection range. Passive infrared sensors have a fixed range and angle. Detection may fail if a person approaches from outside the area. No differentiation. Cannot distinguish between a human visitor and other sources of heat or movement. No visitor confirmation. Doesn't give feedback to the visitor. No light or sound to confirm the bell rang. Weather sensitivity. Outdoor PIR sensors can be affected by rain, fog, or extreme temperatures unless properly enclosed. Security risk if misused. If used with a camera or identification system, it could be exploited to risk occupancy without being noticed. Coming to the conclusion, the automatic doorbell ringer is a smart and efficient system that enhances convenience, hygiene, and accessibility by eliminating the need for physical contact. By using motion sensor and simple microcontroller, it ensures that residents are automatically alerted when someone approaches the door. While the system is cost-effective and easy to implement, it does have limitations such as potential false triggers or limited detection range. Overall, the project serves as a practical example of how automation can improve daily life. It offers strong foundation for future enhancements like camera integration and smartphone connectivity. References. Here are some references you can include in your document project or presentation. Here's some support circuit diagram.org. And this from Arduino official documentation. And this from Last Minute Engineers. This from Engineers Garage. And this from microcontrollerslab.com. I have gathered data from all these reference using all these references. Uh, Thank you for listening to the presentation.